Hello, today we're going to look at acceleration 2 and some practicing of physics equations v squared minus u squared equals 2as. We've previously seen the equation acceleration equals change in velocity divided by time taken. So that's all being well if you know the difference in the velocity, v minus u, the end minus the start velocity, and also how long that you've been travelling for. However, sometimes you might see an example like this one. A car was moving at 2 meters per second and increased its velocity to 5 meters per second. It took 1 kilometer. Calculate the acceleration of the car. Now in this example, we don't have the time taken, so we need to use a different equation. And as I said at the start, that is v squared minus u squared equals 2 times a times s. So that's the end velocity squared, take away the start velocity squared, and that's equal to 2 multiplied by the acceleration multiplied by the displacement or the distance travelled. This equation is known as one of the equations of motion of physics, and it describes how an object moves with a constant acceleration. So if an object is falling down to Earth, if it's nearby, then the constant acceleration that we say is 9.8 meters per second squared of free fall. Before we start though, we need to think of a strategy, and the first strategy I would recommend is Suvat, S-U-V-A-T. So let's just have a quick look at what these letters stand for. So S is the displacement measured in meters, U is the start or initial velocity in meters per second, V is our end or final velocity, again meters per second, so U is before V in the alphabet, so U comes before V, U is the start, V is the end. A is for acceleration, so meters per second squared, so that's how quickly you change your velocity. And T stands for time, measured in seconds. Now the eagle-eyed amongst you will notice that time didn't feature in the equation that we're looking at today, so we can ignore it for now. So let's just remind ourselves of the question. But as well as talking about Suvat, we still need a further strategy in order to use this equation, because one of the skills we need is to rearrange it, and that can be quite tricky in the form that it currently is in. So I would recommend writing this strategy out, or certainly writing the key parts of it. So let's just go through it. So to start with, we like to bug. Now that stands for box, the command word, so find out what we need to do, so go around it with a box. Underline key information, so in this case it's numbers, but we also then need to start converting units, and once we've done that we can go, but we must remember to check at the end. Once we've got the key information, we can then start searching for an equation. Now in this case all the equations will be v squared minus u squared equals 2as, but in a real life example in an exam we need to find the right equation first. We then need to substitute our numbers in. Now I would highly recommend always writing the equation out every single time, and then you can just put the numbers in underneath. It's a really good habit to get into. Finally, we need to calculate the answer, and of course that might include rearranging the equation to find the unknown. And we need to also remember that we can always use a calculator in physics, so keep that calculator to hand. Then finally, remember the unit at the end. Some questions give you the unit, but a lot of them, they'll expect you to know what the units are. So following the strategy then, we're going to bug. So we're going to box the key things, so calculate the acceleration, that's what we have to do. We're going to underline, in this case I've just highlighted the key things. And the final part is to convert the units. So meters per second, that's standard unit. Meters per second, that's standard. 1 kilometer, we need to convert. So I've written Suva or Suvat, but we know that T doesn't exist in this equation. And then it's a case of writing the values in. So I've converted 1 kilometre by multiplying by 1,000. There's 1,000 metres in 1 kilometre, so that's why I've written 1,000 here. The start speed or start velocity is 2, and it's increased its velocity, so that bit is the end velocity. Calculate the acceleration, that's our box, and I'm just going to put a question mark just there for acceleration. That is what we need to find out. Now we need to find the equation, and in this case we've got the equation, v squared minus u squared equals 2 times a times s. And now we're going to substitute the values in. Now I highly recommend, because you've written the equation here, we can now just start putting the numbers underneath, and then it all matches. So we can see the v squared is our 5 that needs squaring still. Take away the u squared, so that's going to be 2 squared. And then that equals 2 multiplied by the acceleration, that's our question mark. I'll just write an A for now. Multiplied by 1,000, we converted before. For the next line, we're going to calculate the answer. Reminder, we can use a calculator, so we might be able to do it in our head, but for other questions we might not. So 5 squared, 25. Take away 2 squared, which is 4, and that equals 2,000 because that's 2 multiplied by 1,000. And then we need to remember that the a still needs to be included. So we're going to further simplify. So 25 take away 4 gives us 21. And then that then equals 2,000 multiplied by the acceleration a. So now we need to rearrange. So we need to divide this side to get a by itself. So divide both sides by 2,000. So that's then 21 divided by 2,000, and that's going to equal a. And then we can further simplify that in a calculator. Acceleration equals 0.01. And then the final bit that's often forgotten, we need to remember the unit. So we know that acceleration, its unit, is of course meters per second squared.